Hello everyone. Today I am going to show you step-by-step guide for using Oracle Cloud Infrastructure Compute Auto-Scaling with the load balancing service. So first of all, open the cloud sign-in page oracle.com/cloud/signin.html, and once you open the page you will be asked for the tenancy name. So in my case this is my tenancy name. Click on next. Provide your username and password and click on sign in. And first thing we are going to do is create a VCN. So for creating VCN, just click on navigation menu, networking, virtual cloud networks. So we have two options to create a VCN. One is create VCN and another is start VCN wizard. So if you are a network guy, then a create VCN is appropriate for you. You have to manually create the service gateways, internet gateways, NAT gateways. In case of a create VCN only, so if you go with the start VCN, so if you are a developer and you are not so much familiar with the network and all this stuff, just click on start VCN wizard and it will create all the required components within a VCN. So after that, by default it is selected. VCN with the internet connectivity is selected. So just click on start VCN wizard. So it will ask for the VCN name. Let's provide VCN001 as a VCN name, and you can go with all the default settings. So in this case, my CIDR is 10.0.0/16, and my public subnet is 10.0.0/24. Private is 10.0.1.0/24. So after that, click on next. Just if you want, you can review the changes, review the VCN configuration that is going to be created. So once you are happy, click on create. Now you can notice the VCN creation is done, subnet creation is done, internet gateway, and everything is done. So once you have created the virtual cloud network, click on view virtual cloud network button to view the VCN details. So we have two two subnets. One is public subnet and another is private subnet. We have an internet gateway, security list, DHCP option, NAT gateway, and service gateway. Okay guys, pause the video and create VCN in your OCI console. Next step we are going to do is create a public load balancer. Basically what we are going to do is we are going to create a backend web servers and we will route all the traffic through public load balance. So basically we will add a IP address of a public load balancer in the DNS record and we will access through a load balancer. And at the back end we have a auto scaling compute instances. Okay, let's create a public load balancer. For that, click on navigation menu, networking, navigation menu, then networking, then load balancer. Click on create load balancer. Provide the name of load balancer. In my case, I am providing LB_Nepal OUG. So visibility of my load balancer is public because it is facing towards internet and it is serving a web traffic to everyone in the internet. So I have created public subnet. So if you have any requirement where the request comes from only VCN and is and is visible within the VCN only, then you can select private subnet, a private load balancer also. After that, I'm happy with the bandwidth. Select the VCN, select the subnet, click on next. So load balancing, in case of load balancing policy, I am happy with the weighted round robin. We have a 3 load balancing policy: round robin, IP hash, and the least connection. At this time, I do not have any backend server, so there is no meaning to add a backend right now. So if you even click the add backend, then it will not show any compute instance right now because there is no compute instance running right now. I am happy with the health check policy, protocol HTTP, port 80, 10,000 millisecond is the interval of a health check, timeout values, and the number of retries. Click on show advanced option. So to provide a backend set name. You can provide any backend set name, but I prefer to provide proper backend set name. So it is like BS underscore Nepal OUG in my case. After that, click on next. Here you can provide a listener's name, listener underscore Nepal OUG. And the traffic the listener serves is HTTP, so I am selecting HTTP, and port it, in case port it is serving is 80. So after that, oops, my scrolling 80. Then after that, you can click on submit. Okay, my load balancer is creating in progress. So it's creating. Okay, my load balancer is created and is active now. Okay, guys, pause the video and create load balancer at your end. And next thing we are going to do is create a file storage to store all our web contents in a file storage. Basically what we are going to do is we are going to create a file storage and place all our web content on there. And we will mount the file storage in multiple compute instance. That will make sure that the all web servers are serving the same content to the client. So for creating file storage, click on navigation menu, click on file storage, and click on file system. Click on create file system. If you are happy with the naming and all this stuff, just you can click on create. But in my case, I'm going to change the name of the file system. Just provide the file system name as a web root Nepal OUG. And rest, I am happy with the rest of the configuration. So rest of the namings and all this stuff. So just click on create. Once my file system is active, you can click on 3 vertical bars and click on mount command. And here is the ingress and egress rule I need to add in the security list. And these are the command for mounting NFS mount point. So just copy this mount command. I need to use it later. So just I paste it in the URL itself. So for the recording, for the recording, I have just provided it in the URL, browser URL. Okay guys, stop the recording and create a file storage in your OCI console. Our next step is to add our rules in a security list for a file storage. So for that, click on navigation menu, networking, then VCN. Sometimes it may take times. In that case, you can refresh it, and refresh works. Okay, here is my VCN. Click on VCN. Click on public subnet. Click on default security list for VCN 001. So if you add a egress and ingress rule in default security list, then it will be applied to public and private subnets. Okay, click on add ingress rule. So in my case, source is from anywhere else. It's a 0.0.0/0. Protocol is TCP and destination port is, first of all, I'm going to allow HTTP, then 111.2048.2050. Some meaningful description. Click on add ingress rule. Once you add the ingress rule, it looks something like below. Add UDP rules. Source from anywhere, protocol is UDP, source protocol is anything, and destination is 111 and 204. Again, some meaningful description. Okay, add ingress rule. Once you add it, it looks something like this. Okay guys, pause the video and add ingress rule in a security list. Our next step is to create a custom image with all required settings and the configuration. So basically what we are going to do is we are going to create a compute instance with, and we will install all the required packages over there, and we will configure it and create a create a custom image from the running compute instance. Okay, for that let's create a compute instance. For that, click on navigation menu, and compute an instance. Click on create instance. Provide the name of instance. It could be anything. Let's name it as wave1. I do not change the compute, change the image itself. I am happy with the Oracle Linux 7.8, but I need to change the shape of my compute instance, because always free eligible has a limitation of the number of compute instance in a account. So I need to change it to something which is, basically I am using trial account, so I am able to create few more instance with a not always free eligible one. So basically, let's select the VM standard E2.1, select the shape. I'm happy with the VCN and the public subnet, and make sure you have assigned a public IP address. And after that, add a SSH key, paste the SSH key, click on create. Okay guys, pause the recording and create a compute instance. Our next step is to log into the compute instance once it is running, and once we log into the compute instance, we will install all the required packages and configure it and create a mount entry and mount the file storage. Let's wait for a few minutes. It may take 1 or 2 more minutes. So the creating instance is in progress. It's 15% completed. Yep, it's done. So once it is done, you can notice a public IP address over there. Here is a public IP address. Just copy it. Open your terminal. So in my case, I'm using itom2. Let's SSH using user OPC at IP address. Oops. Type yes. Yeah, now you are logged in. Now we need to install HTTPD, PHP, and stress package. So we need HTTP to serve the web request, PHP for the dynamic scripting. We will use some dynamic scripting to print the host name, which host name is serving to the client request. And we will use up stress package to generate a CPU load, virtual CPU load in a compute instance. After that, we need to configure the packages. So in this case, I am adding HTTPD to start at startup. So basically, whenever the machine gets reboot or machine gets started, the Apache will start at its own. Next step is start Apache, and another step is to add HTTP service in the firewall and reloading it. After that, we need to insert a mount entry in a etc tab. So for that, just sudo to root, switch user to root. It's always better because sometimes sudo will be a little bit hard. Okay, type echo and the entry in a fs tab. Now you compare the mount command that is provided in a file storage mount. So I have just copied it in the browser. So let's compare it. The IP address is 10.0.0.5. In my case, I have set it to 4. So let's make it 5. And NFS mount point is web root WB web ROT root Nepal OAG. So it is perfectly fine. And I'm going to mount it in a var www HTML mount point. So type enter. Now you can just simply mount /var www HTML and your file storage should be mounted. Check it with df-s var www HTML. Yep, the file storage is mounted, and we added it into etcfs tab so that it will be persistent. So every time it get rebooted, it get mounted at its own. Okay, our next step is to change AC Linux into a permissive mode, because by default it is in the enforcing mode. In enforcing mode, you are not allowed to access web pages from file storage. So let's open with VI. Save it. Now check here current SE Linux mode. For that, get enforce. It is still enforcing, so change the enforcing with set enforce command. Now it become permissive mode. So after that, let's create a dynamic page index.php inside the file storage. So basically what we are going to do is we are printing the page is served by then the host name of the compute instance that it is serving. So after that, you should be able to browse the page using the public IP address. So let's copy the public IP address. Public IP address is this one, is public IP address. Okay, we do not need it anymore. So just paste it, then index.php. This is the page we are going to browse. Okay, I am able to see the page. So that this means all my configuration is right. Okay guys, pause the video and configure, log into the compute instance and configure the Apache. Okay, our next step is to make sure that all changes are persistent and it will be saved during the reboot. So all the changes we made should be reflected after reboot. So let's reboot the compute instance. Okay, my current compute instance is rebooting. You can see it from here also. If you refresh the page, then it may take time, or the site cannot be freezed. So basically my compute instance is in the rebooting process. Its state is rebooting. Let's wait for a minute. If you have configured it properly, then the page should be displayed after the reboot also. All the changes you made is persistent and saved during reboot. Okay, the compute instance is rebooted, and let's refresh the page. It may take some time to start up everything. Let's refresh once again. One more time. Yep, it's back again. So all the configuration I have done is proper and is working. Okay, our next step is to create a custom image from this running compute instance. So just click on more action, just click on create custom image. provide the name of image, image underscore Nepal OUC. Just click on create custom image. Okay guys, if you notice, then the state of my compute instance has changed to create compute instance, and the compute instance will not be available during the creation of the custom image. So there will be a downtime in a system. If you are doing it in a production, you should be aware of the downtime. It will result, there will be outage. So be careful while doing it in a production system. If you check the web page, then it is not available right now because the compute custom image creation is in progress. Okay guys, pause the recording and create custom image from running compute instance. Now our next step is to create a compute instance using the custom image we have created just now. So, and there are a limitation in a number of compute instance in a trial account. So I am going to destroy, I'm going to terminate this compute instance that I am using for the creating custom image. Basically, main purpose of creating this compute instance is to just fetch a custom image from the compute instance. And the custom image contain all the required packages, and it is configured. The Apache is configured, well configured to start at a startup, and firewall rules are permitted, and the mount entries are being added. So my compute instance is running once again. So just verify that your custom image has been created properly. So for that, navigation menu, compute, and custom image button. I can see my custom image has been created just now. So let's destroy the compute instance. Let's terminate it. Basically, I'm terminating it because I have a limitation in the number of compute instance in my trial account. And there is no meaning to keeping it because it is not in use for me. Okay, after that, let's create and compute instance with a custom image. So let's name it as a web2 compartment is my root. I'm going to create it in a root compartment, although it is not good practice to create it in a root compartment itself. I'm doing it for the simplicity. Now we need to change the image. So click on change image, click on custom image, select the custom image. So in my case, image underscore Nepal OEG is a custom image I have created from the wave1 compute instance. After that, change the shape because always free has a limitation in the number of compute instance. I need at least 3 or 4 compute instance there, and I believe there is two limitation of 2 compute instance in case of always free eligible. Select VM standard .e2.1, select shape, happy with the PCN, happy with the subnet. Okay, let's paste the SSH keys and click on create. And once this compute instance is fully provisioned, you can directly access the index.php with the public IP address of this compute instance, right? Because it has fully configured Apache, and the configured full Apache is installed, Apache PHP and stress package is installed over there, and we We have configured Apache, we have created index.php and created a mount point for the file storage. So basically it's a fully configured, we have created compute instance from the fully configured compute instance image, so it should be running without any our effort. So basically you do not even need to log into the compute instance via SSH to configure anything. Let's wait for a minute. Once create instance is 100% complete, I'll grab the public IP address and append slash index.php at the end, and I should be able to see the page without any changes. Here it is. This is my public IP address. Let's paste it and index.php. Okay, it's being shot by Web2. So everything is perfect till now. Okay guys, pause the video and create a compute instance with a custom image. Our next step is to create an instance configuration. Basically, instance configuration contains all the details about the instance, which image to use, what are the other configuration of the compute instance. Everything is regarded in the in an instance configuration. So just for that, just click on more action, click on create instance configuration. And this one is the simplest one. Just type the name of the configuration and click on create instance configuration. Here it is. Okay guys, pause the video and create an instance configuration from the running configuration. And guys, we have a hands-on lab guide, so if you have any trouble, you can follow the hands-on lab. We have more details in the hands-on lab and the screenshots. You can follow from there also. We will include hands-on lab guide in the recording itself, so you can follow the hands-on lab guide also for more details. Okay, after that, the next step we are going to do is we are going to create an instance pool. So basically instance pool are used to create a multiple compute instance from the same configuration and within the same region. And basically we can say it as something like a group of the instances in a pool. So for that, click on create instance pool. Give the name of instance pool. So in my case, instance pool Nepal OEG is my instance pool name. Click on next. Okay guys, here is the part of the availability domain. So if you have only one availability domain in your region, then just select the primary VCN, subnet, and click on attach a load balancer. So in my case, right now I am in US Ashburn and I have a 3 availability domain, and I want to basically create my compute instance from the pool in all 3 availability domains. So I am adding availability domain. So guys, if you have only one availability domain in your region, make sure you do not click the add availability domain, and the next step I'm going to do can be skipped. need to be skipped. So add availability domain, let's say AD2. So basically my second or my next compute instance will be created on AD2 with the VCN 001 as a VCN name and the public subnet. Let's add the third third availability domain, VCN 001 and public. So basically the compute instance that is being scaled out in my case will be created on all three availability domains. So they are scaled. So after that, click on attach a load balancer. We have created a load balancer earlier, right? So just provide the name of the load balancer we have created, LB underscore Nepal OUG. Backend set is BS underscore Nepal OUG. Port of our listener is just 80, and we are using as a primary PNIC. So just click on next. So here is the instance pool configuration. It's perfectly fine. Just if you want to review, you can check it and click on create. Okay, my instance pool is running. Right now, let's edit the instance pool and provide the number of instance as a 3. So basically what I am trying to do is, so I am going to scale out all 3 compute instance and want to verify either it will be successfully provisioned, successfully scaled or not. So just click on save configuration, save changes. After that, it starts scaling and we can notice some work request has been added to this work request section. It may take a minute. Yep, here it is. So basically 3 compute instances are in progress. I am planning to provision scale out 3 compute instance in a pool. So it's always better to create a 3 compute instance and make sure that they will be scaled out properly. Okay, it may take few minutes. Okay guys, pause the video and create instance pool. Once all the instances are created and attached to load balancer, next step we are going to do is create an auto scaling configuration. Yep, one is succeeded. Very soon we will notice more succeeded. Okay. Okay, if you can notice, then all my compute instances are created in a pool, they are scaled out, and they are attached to load balancer. So basically it means that there is no problem at all in scaling and attaching to load balancer. Okay, our next step is to create an auto scaling configuration. So for that, just click on more action and click on create auto scaling configuration. So the compartment is root compartment, auto scaling. So to provide the auto scaling name, let's make it as a Nepal OEG, auto scaling hyphen Nepal OEG. And I guess it should provide the instance pool name. Let's cancel once again, refresh it. Okay, do it once again, click on more action, click on create auto scaling configuration. Here it is. So the instance pool is already selected. So change the name into autoscaling -config -nepalog. My name of the instance pool is instance pool -nepalog. Click on next. So here is the policy. So we have a metric-based auto-scaling policy and a schedule-based auto-scaling policy. So let's check the schedule-based first. So in case of schedule-based, let's say if I have a requirement to scale out up to 3 compute instance at my daytime at 9 a.m. UTC, then what I can do is let's give the name as day size is 3. So basically 3 compute instance will be scaled out during daytime, and you can choose the value from here. This is the predefined value 6 p.m. UTC or something else other. Okay, I will go with the custom one. So 0 is the minute value, 9 is the hour value, and day of the month is any day, any month, blank, day of the week is blank, and the year value is 30. Okay. So this means that every day at 9 a.m. UTC, my compute instance are scaled out to 3 compute instances. Okay, add another policy. Let's make it as a night 1, and we already have a 6 p.m. UTC rule for it. So I picked it from the quick start. So basically it means that the minute value should be 0 and the hour value should be 18, that is 6 p.m. and any day, any month, and any year. So this means that every time after 6 p.m. the number of compute instances are scaled into 1, and after, sorry, it's a scrolling of mouse created issue. And every day at 9 a.m. my compute instance are scaled out to 3 compute instance. Okay, I'm not going to try this. I'm going to try the metric-based auto-scaling. So in case of metric-based auto-scaling, let's say, in case of a metric-based auto-scaling, so it will scale in and scale out on basis of the metric value that we have defined. So let's change the name of the auto scaling and the cooldown time. So cooldown time is number of time in second that it should continuously exceed the threshold value for scale out and for scale in. So let's make it scale out operator is greater than 40 and number of instance rate is 1. So in this case, let's check the performance metrics as a CPU utilization. So in this case, if my CPU utilization of overall computing instance, if there is 2 compute instance, then both the compute instance, the average of both the compute instance should exceed the CPU utilization to more than 40 for continuous 300 seconds, then one of the instance get added. So this means if the number of compute instance is less than minimum and the CPU load, average CPU load is less than 40, then 40 for continuous 300 seconds, then one compute instance is added to the pool. In the same way, if the compute CPU threshold is less than 10 for continuous 300 seconds and is greater than the minimum number of compute instance in a pool, then one compute instance is removed from the pool. Scroller again. So the minimum number of instance in a pool is 1. So at any cost, one compute instance will be there to serve the request, and the maximum that I can afford is a 3. So basically there will be a 3 compute instance at max, and at minimum there will be 1 compute instance. and the initial number is 1. So at first there will be one compute instance. As the CPU load grows, and if there is a CPU utilization more than 40 and for continuous 300 seconds, then one more compute instance is added if the compute instance is less than 3. So after that, click on next, review the process, and click on create. Okay guys, pause the video and create auto scaling. Okay, our next step is to see scale in and scale out in live. So let's see it. And one thing if you have noticed, is that we have used a public load balancer, right? So we should be able to access our web pages by public load balancer, IP address of a public load balancer. So to get a IP address of load balancer, just click on navigation menu, networking, and load balancer. So here is my public IP. Just click on it, paste it. Then we have a index.php base. Yep, here it is. Now we log into this compute instance and we will create a load over there. Okay, for that, just log into that compute instance. Check the IP address of public IP address of the instance. So right now I have all 3 compute instances running, but from them only one is serving. It's a web 2 hyphen 864,337. So let's wait for a few more minutes. Okay, if you notice, then the 2 of my compute instance in a pool is terminating, right? So out of 3 compute instance, they were in the pool. 2 are terminating and 1 is running. So just copy the public IP address and log into the compute instance using SSH. Type yes. Now we have a stress command. Here it is. If you check the current server load, then it's 0, right? So once you execute this command, yes, load average become extremely high. We can use the top command to check the load continuously. Let's minimize it. Is it possible to minimize? Okay, we can do this way. Okay, right now I have only one compute instance that is running, and if I access the page, it gets served by only one compute instance. And if you keep on checking the load for entire 5 minutes, then you will notice that the compute instance will be provisioned and will be ready to serve. So guys, let's wait for 5 more minutes. These are the matrix value from where you can see the load of the CPU. So it increased up to 100 after 36. So once it is 41, now you will notice the instance pool state become scaling at any time, right? So after at 341, it becomes scaling because the CPU load, if you notice, the CPU load has increased to 100 at 336 UTC. Okay, we can check the work request at backend. Right now we can see create instance in a pool. Instance creation is in progress. So after that, the next task is to attach it to load balancer. If you have noticed that the CPU load of one compute instance is 100, right? It's 100% use. And if another compute instance get created, then the CPU load, the average CPU load become 50 because one have 100 and one have almost 0. So it's between 45 to 100. So the matrix value works on basis of the average CPU utilization. So it's 41 again. If you check the compute instance, then you will notice the one of the compute instance is provisioning right now. It has a public IP address 132.145.139 and 172. Let's wait for a few more minutes. Once it is fully provisioned, then we can access it via load balancer. Previously, when there was only one compute instance, our request gets solved by only one compute instance. After that, when we do refresh to this page, we will get two hosts serving our request. Okay. Okay, the task is completed and it is back to running. And if you check the instances, then right now I have two compute instances in a pool. And if I do refresh, then I will notice there are two compute instances serving my request. So right now, let's refresh it. Right now it is served by web2 hyphen 705,025. And if I refresh again, then it will be served by 864,000. So there are two compute instances at the back end serving the request. Okay, let's wait for 5 more minutes because my CPU utilization is still over the threshold for scale out. So if you notice, the CPU load will decrease and it will around 45 to 50. Here it is. So the CPU load is 50 right now at 3:45 a.m. UTC. So let's wait for 5 more minutes. So it's already 5 minutes. So it will be changed to scaling at any time. Yep, it has converted to scaling. And if you check the work request, then you will notice instance creation is in progress. Okay, it's almost done. Once it is done, we can see the number of instance in the instance page is 3 now. I have this one, and this one as a 3 instance in a pool. And now if I refresh the page, then I will get 3 compute instance serving. One is 909, 909,929, 705, 025, and 864. So this way, all my 3 compute instances serving me right now. Okay, let's kill the stress process. Oh, it should be awk. Okay, all my stress process is killed, and if I check the CPU load, then we can notice the CPU load is gradually decreasing, And if you check the matrix value, then you will notice the CPU utilization is gradually decreasing. Once the total CPU utilization is less than 10%, then you will notice that it will scale in and remove one compute instance from the pool. Let's check the CPU utilization in a matrix. Yep, it's already below 10 now. So at 3:57, it's below 10. So at 4:02 a.m. in the AM, then it should scale. It should start scaling in and remove one compute instance. Let's wait for 5 minutes. Okay, in any time it may be converted into scaling. The status of this instance will become scaling, and we can notice that the instance termination will be in progress. There it is, scaling is in progress. So if we check the work request, then we can notice instance termination in progress. So guys, it will take around 2 minutes to completely terminate this instance and detach from the pool. And once it is done, our web request will be served by only 2 remaining compute instances. And if the CPU utilization is still below 10%, then another compute instance will be terminated in the similar way. So if you check the resource, it is below 10%, and we have defined it in the auto scaling policy. So if you check the auto scaling policy, then here it is. You can check the rules. If the CPU utilization, we text as a CPU utilization. So if the CPU utilization is greater than 40%, then add a compute instance, one compute instance. And if the CPU utilization is below 10%, then remove one compute instance. And scaling limit is minimum 1, so there will be always one compute instance. Either the CPU utilization is below the threshold, there will be always one CPU, one compute instance, and there will be a maximum of a 3 compute instance, even though the CPU utilization is above the threshold for scale out. And the initial number is 1. So basically at beginning it will be 1, and it will increase 1 if the CPU utilization is greater than 40, and again it will add up 1 till the number of the compute instance becomes 3. And again, if the CPU utilization is less than 10 for entire 300 seconds, then one compute instance will be removed. And if it continues, then again one compute instance will be removed, and we're left with the one compute instance. Okay, let's check the work request. Okay, there it is. Terminating the instance is in progress. So if you check the compute instance right now, then it will be in a termination state. Yeah, there it is. Oh, oops, sorry. Yep, it is in terminating state. So at this moment, if I browse my page, then it will be served by only 2 compute instances, 864,337 and 909, 929. So there are only 2 compute instances serving my request. And if we leave the CPU utilization below 10 for more 5 minutes, then definitely another computer instance will be terminated also. Yeah, if you notice, then only 2 computer instances is running and one is terminated. So let's wait for 5 more minutes. It's around 4:09. If you check the utilization CPU utilization matrix, then it is definitely below 10. So yeah, it's in scaling mode. So if you check the work request, then you will notice termination is in progress. Once it is terminated, then there will be only one compute instance left and our request will be served by only one compute instance. Okay guys, after a few minutes, we have detached load balancer 100% completed. Instance termination is 30% completed. So if you check the instance, then it will very soon mark as a terminated. Yeah, it's in a terminating state. So now if you check the web page again, then it will be served by only one compute instance. Okay guys, I hope you enjoyed this video, and if you have any problem, then please let us know. You can drop an email at info@nepaloeg.com, and you can ask any issue. If you have any issue, then just you can ping us in the WhatsApp group. It's Nepal OEG WhatsApp group also. And please share your feedback and comments about the video. Thank you. Hope you will like it.